Hey everyone, welcome back to this master series on learning coding patterns. Today we are going to solve a very amazing, very interesting question. The question name is maximize the confusion of an exam, and the question number is 2024 of LeetCode, and we are going to solve this question using dynamic size sliding window approach. Okay, so in simple words, what this question is asking, this question is saying us return the maximum number of consecutive T's or F's in the answer key after performing the operation at most k times. Wow. Okay, so what are these T's and F's? So basically the question is that suppose there's a teacher, and that teacher is making a question paper. Now that teacher wants to confuse his or her students, and now what he or she wants is that the aim is to make a consecutive questions answer key. For example, like all the T's are here, all the F's, or all the F's are there and then followed by T's, so something like that. So now what is our aim? Our aim is with this given answer key, what is our aim? Our aim is to come up with such a solution that contains maximum number of consecutive T's or F's depending on the case of k. Now what is k? K is that number of times we are allowed to flip either T or F. Okay, and suppose in this situation what we can do, k is 1, which means like either we can flip this F and make it T. So the consecutive T's that we will get maximum at most is 5. Okay, so we will get 5 T's here if we will flip this F. Or let's say we are deciding not to flip this one but rather just this F. So when we will flip this F to T, what will become? T, 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 T and T. So again we will get 5 T's. Okay, so this is our aim. But let's suppose rather than T there were F's, and here in F's position let's say there were T's. So what we would have done, we would have, rather than changing F, we would have selected T and then changed them. So in order to get maximum consecutive F's. Okay, so this is kind of scenario. Okay, so now let's build up the intuition how we are going to solve this question. Okay, so again we are using dynamic size sliding window, so I have come up with this window. This window is right now appearing very small, but eventually when this window will grow up, you will see like it's a pretty big window. Okay, now how things are going to work. So we have this answer key, okay, and these are the indices which are representing, like 0 index is representing T, and for the first index is representing T, the second index is representing question number 3, which is F. Okay, now here we have k. So k is again the maximum number of operations or maximum number of flips you can do, which is 1. So you can only change one question in this answer key in order to get either maximum T's or maximum F's. Okay, now I have introduced these 3 variables. So this one is count, and what count will contain? Count will contain the count of T's and F's in our window. So whether like if I grow my window to this size, so what will be the count? The count will be 4 T's and 1 F, because right now inside our window there are 4 T's and 1 F. Okay, now again put it back to this position, because here if you see there's L and R, and these are left and right pointers, and we are going to initialize them at the 0th index. Okay, now we have operations required, and what this means is that this variable will tell us that how many operations we can do in our window, and if let's say this operations required will surpass this k, which means like if let's say operations required are 2 and k is 1, then we will see like what operations we have to do in order to change this operations required again back to 1. Okay, basically we are going to shrink our window in order to make some adjustments that can allow us to have operations required lesser or equal to k but not greater than k. Okay, And then finally we have this max questions number. So number of max questions. Okay, so what this will tell us, this will tell us the maximum number of questions inside our window. For example, if I again expand this window, so here we have 5 questions. So maximum questions that our window will contain at a given moment, max questions will represent this part. Let's say our window will come to this position. Now we have 2 F's, which means like there is a problem, operations required is now 2. So what will happen is that we will shrink it back to this position. Now the maximum questions inside our window will be 3, but if you look at this position, the maximum window will contain 5. So our aim is to focus on this variable and return the maximum amount whatever we can. So if it will reach out to 5th position, let's say like 5 questions, so we will not change it to 3, we will let it remain 5 unless and until we find such a window size that surpasses this max questions number. Okay, whatever that number will be. Cool. So whatever I've said just right now, that all was just to build an intuition so that you can at least start to map things out in your mind, okay, how things are working. And now let's jump towards understanding this question visually. Okay, so here we have our window, we have left and right pointer. Right now the window size is very small because we are just starting out, and left and right pointer are initialized at position 0, okay, 0 index. Okay, so at the moment at 0th index we have t. So what we will do, we will first of all come here and update this count, because at the moment our window contains 1 t, okay, and 0 f's. Then what will happen, then we are going to focus on this operations required part. And in the operations required, how we are going to calculate this operations required, simply we are going to subtract left from right and then +1. So this will tell us the total number of questions in our window. Okay, this part, okay, you can say this part is basically representing this max questions. Okay, now what we will do, we are going to subtract, whichever the maximum count we will have, either of t or f. Okay, for example, here in this situation t is greater than f, so what we are going to do, we are simply going to minus this t, let's say. Okay, now what will happen, so let's calculate it. So we have right is again at 0 position, so 0 minus 0, and then we have +1, so +1. Why this 0 0? Because left and right pointers are at 0 index. And then +1 minus the t count, okay, the count, so it's -1. So the final answer will be 0, because 0 minus 0 is 0, +1 and -1 will make it 0, so 0 plus 0 will be 0. Okay, now operations required is 0, so max questions will be at the moment in our in our window will be 1. Why only 1? Because I said if you just look at this part, 0 minus 0 is 0 and then +1. So if you just look at these 3 numbers, you will get 1. So that's why 1. And logically speaking, like right now we have just 1 question. Okay, so that's why our window contains 1. Now we are going to expand our window. Why we are going to expand our window? Because the operations required size is 0, which is lesser than k. What I told you earlier is that if operations required size is greater than k, then we are going to shrink our window, or else we are just keep getting expanding. We are just going to expand our window. So here we have expanded our window, and now we have again found a t at first index. So what we are going to do, we are going to update our count. Now in our window we have 2 t's and again 0 f's. So now let's count this operations required. So let me remove this part, and then r minus l. So r is now representing first index, so 1 minus 0 because left is still at 0th index, plus 1, and then minus, so whichever count is greater. Right now t's count is greater, so 2. Okay, so 1 minus 0 is 1, 1 plus 1 is 2, 2 minus 2 is 0. So again operations required is 0, but if you consider this part, just this part, so maximum questions inside our window is 2, these two. Okay, so let's make it 2. Okay, now let's expand our window again. So we have reached to this point. Now we have found 1f, so let's come here and update the count. So right now we have 2 t's and 1 f in our window. Okay, now we are again going to calculate operations required. So come here, and right is at second index, so 2 minus 0, left is still at 0th index, plus 1, and then minus t's count. So why t's count? Because t is greater than f, so 2. Okay, now what will happen? So 2 minus 0 is 2, plus 1, so 2 plus 1 3, and minus 2, so 3 minus 2 is 1. Now operations required is equal to k. Still we are not going to shrink our window. Why? Because operation required has not surpassed k. Operation required is not greater than k. Okay, so what we will do, we will simply here update our max question. So right now we have 3 questions inside our window, so now rather than 2 we are going to write here 3. Okay, cool. So let's expand our window further. Now we have found 3 t's and 1 f. This one is t. So what we are going to do, we are going to update the t's count, and we have found 3 t's and 1 f inside our window. Now again let's calculate operations required part. So right is at 3rd index, left is still at 0th index, and plus 1, and then minus t's count, which is 3. So 3 minus 0 is 3, plus 1 4, and 4 minus 3 is 1. Again it is equal to k, not greater than. So what we are going to do, we are going to update our max count with 4. Okay, there are 4 questions inside our window. Now we are going to further expand our window, and now we have found another t. So at the given moment inside our window, how many t's how many t's are there? There are 4 t's and 1 f inside our window. Now again come to operations required part, and 4 minus 0 plus 1 minus 4. So 4 minus 0 is 4, 4 plus 1 5, 5 minus 4 1. Okay, so here we have found 1. Again it is similar to k, it is same as k. So what we will do, we will just update the max questions count, and it will become 5. Now here is an interesting part. When we will expand our window, we will encounter another f. Now the f's count will be 2, so 4 t's and 2 f's. Okay, now let's calculate operations count. This one is going to be interesting. So right is at 5, minus left is at 0, plus 1, and 4 t's. So the final answer is going to be 5 plus 1 4, and then minus 4, 5 plus 1 6, and minus 4. So final answer is going to be 2. Now operations required has surpassed k. 2 is greater than 1. So what we are going to do, we are going to shrink our window. How till which point? Let's say if we will shrink it to this point. So what will happen? Now how many t's are there inside our window? There are 3 t's and 2 f's. Okay, so let's update these count as well. So here we have 3, so 3 t's and 2 f's, right? So now let's calculate operations required again. So let's remove this part, and right is at 5, so 5 minus left is at 1 plus 1 and minus t is 3. So 5 minus 3 is 2, right? 2, because 1 will cancel out with 1, so minus 1 will cancel out with plus 1, so what we will get 5 minus 3, which is equals to 2. Again, it is greater than k. So what we will do, we are further going to shrink it. So now our window contains 2 t's and 2 f's. Again, let's update the count of t, so it is 2. Okay, now again we are going to calculate operations required. So okay, right is at 5 minus left is at 2 plus 1 minus 2. So 5 minus 2 is 3, 3 plus 1 is 4, 4 minus 2 is 2. So again it is greater than k. So what we are going to do, we are further going to shrink it to this point. Now we have 2 t's and 1 f in our window. So what we are going to do, we are going to update the count, and here we have 2 t's and 1 f. Let's calculate operations required again. This time let's see what will happen. So 5 minus left is at third index, so 3 plus 1 minus 2. So 5 minus 3 is 2, 2 plus 1 is 3, 3 minus 2 is 1. Okay, now operations required is same as k, and it is not greater than k. So what we'll do, rather than shrinking further, we are going to expand our window. But before expanding our window, let's calculate operations required, because I forgot that part. So so here 5 minus 3 plus 1, so 5 minus 3 is 2 and 2 plus 1 is 3. So 3 is lesser than 5, which was our previous count of the, let's say, the largest window size we have got yet. So we are not going to change it, we are going to leave it as it is. Just remove this part. Okay. Now what we are going to do, we are going to further expand our window, and now inside our window there are 3 t's and 1 f. So it means total 4 items. Okay, 4 questions. So come here and okay, leave it as it is, and come here and update this t part. So 3 t's and 1 f. Now we are going to calculate our operations required again. Okay, and right is at 6 minus left is at 3 plus 1 and then minus t count, which is 3. So 6 minus 3 is 3, 3 plus 1 is 4, 4 minus 3 is 1. Again we have operations required 1, which is same as k. So rather than shrinking, what we are going to do, we are going to further expand our window. And again I forgot to calculate the max questions of our window, of a previous window. So it is 4, like there are 4 questions, right? So 4 is lesser than 5, so again we are not going to disturb it, and just remove this part. Now let's expand our window further. So now how many t's are there inside our window? There are 4 t's. So 4 t's and 1 f, right? So again we are going to calculate our operations count, and the right is pointing towards 7 minus 3 plus 1 minus 4. So 7 minus 3 is 4, plus 1 is 5, 5 minus 4 is 1. So again it is same as k, So what we will do, we will check whether the operations required part contains this, the number of questions inside our window is greater than our previous maximum window size. So no. Why? Because there are 4 T's and 1 F. It means like 5 total questions are there inside our window, which is same as the previous maximum size window we have seen yet. Okay, now we would have continued further expanding our window, let's say, but since we don't have any more questions, so we will stop our counter here, and then we are finally going to return what? We are going to return this part, because this is the maximum questions, maximum consecutive T's that we can get from this answer key by flipping only one question, like here in our case F. So by flipping only one F, we are going to get at max 5 consecutive T's, whether you flip this F or whether you flip this F. Okay, so I hope now at least you can understand, like now at least you have understood how this question will work, because whatever I've told you, my aim is that to make it as simple as possible so that you can start to translate this visualization into code. So now let's jump towards the coding part, but I hope like now it will be far more easier for you especially after understanding this question visually. So let's jump towards the coding part. So here we are at LeetCode. The question number is 224, maximize the confusion of an exam, and here we have our test cases, and here we have to code. Okay, so what we are first going to initialize is that left will be initialized at 0, then max questions, which simply means like maximum size of sliding window that we have seen yet. So since we haven't seen anything yet, so it is going to be 0, and then we are going to make count. So count will be a dictionary, and what it will contain, it will contain the count of T's and F's in our window. Okay, so for right, now let's start our loop. So for right in range, length and length of answer key, so our string is answer key, so answer key. Okay, now with each iteration, since both right and left are starting with 0 index, so what we are going to do with each iteration, we are going to update, first of all we are going to update the count of T's and F's in our window. Okay, whatever right will find, right, we are going to update our count accordingly. For example, if right will find T, the T's count will be updated. If right will find F, the F's count will be updated. So answer key and then right, okay, plus equals to 1. So what will happen inside answer key right? So let's say right will start at 0, so at 0 index right will find T, so here there will be T, and since count is a dictionary, so T will be used as key, and the value of T will be updated with 1. Okay, same will happen with F, whatever the right will find. Okay, and then what we are going to do, we are going to count the operations. So operations required, so the formula for operations required was right minus left plus 1, and then minus maximum of whatever is max in count. So whether if T is maximum, if T is greater than F, then this part will return T's value. If F's value is greater than T, then this part should return F's value. So how we are going to do this? Simply count values and then braces. Okay, Now what we are going to do, we are going to use this logic. If ops required is greater than k, remember that part when operations required became greater than k too. So what happened at that part? First of all, we decrease the count. So how we are going to decrease the count? Again, using count answer key and then left. Okay, and so whatever left will be pointing towards the count of that item, that question will decrease. Okay, because we are shrinking our window. Now we are also moving left one step forward, so both left and right started at 0th index. So what we did, let's say this was our window, so now we are going to shrink it, so it will come to this point, so one step further, so it will be shrinked one step at a time. And then finally we are again going to calculate operations required, right minus left plus 1 minus max count of values and braces. So, and after calculating operations required, just like in the visualization, we this part will again going to check whether the ops required is greater than k or not. If it will be greater than k, so what will happen, window size will further shrink. Okay, till the point operations required will become equal to k. Okay, okay, now what we are going to do, let's say we are done with this part. So now what we are going to do, we are going to use our max questions in order to check whether the max questions, the maximum size of sliding window that we have seen earlier, and the maximum size of window that we are currently having, which is this part. Okay, right minus left plus 1. Just like in the visualization, what we did in the visualization was we checked this part, that maximum questions was previously 5, and then we used this right minus left plus 1 in order to check, okay, how many questions are there inside our window, and then we compared it whatever we have seen previously. If the previous window size was greater than our current window size, we are going to we updated max questions variable with that. If it was not, for example, let's say if it was 3 or 4, so what we did, we just skipped that part and we left it as it is, and we moved forward as it was, and we moved forward. Okay, and now I hope this part is now clear. So we are just comparing whatever the size of window we have right now and whatever the size of window we have seen before. And if the previous one was greater, this will assign the previous one's number to max underscore questions variable. If the current size is greater than the previous one, so the new size will be assigned to max questions variable. And finally we are going to return max questions. Now come here and click on run to see the initial test cases. Okay, initial test cases got accepted. Click on submit, and okay, so all the test cases has been accepted. Awesome. So I hope this question is now now you have understood this question clearly. I know, like, this question was, I mean, a bit lengthy, I mean, since it was a medium difficulty level question, but I hope thanks to the visualization and the coding part, now it is at least clear in your mind that how things have proceeded and how this question got solved. If you have any questions for me, please feel free to leave it in the comments. If you have any concern, or if you want to suggest any feedback, please feel free to do so. I am always open for the positive feedback and the constructive feedback as well, so feel free to do so, and I'll see you in the next video with a new question tomorrow. Till then, take care. Bye.